Welcome to our March webinar featuring my esteemed colleague, Bob Latino, who's going to talk about all things reliability engineering and what it means. And, so Bob, forgive me, but I'm going to sort of just tee this up as how Bob sees the world, which I really appreciate because you are a thoughtful, insightful professional who's been around the block a bit. And I mean that in a good way. And just looking forward to hearing your thoughts today. And for everybody on the line, please feel free at any point to raise your hand to comment or ask Bob a question, or feel free to chat in the chat box. And it's likely that we will run longer than the hour that we have planned. So we'll be recording this. And in fact, we are recording it, so you can watch it at a later time if you have to drop off for anything else. And with that, Bob, I will turn it over to you. So welcome, and please build on my clumsy intro.
Thank you, Dean, and thanks for Jessica and you for the assist in this. And yeah, I want to go ahead and get started. And I want to start with a slide about finding common ground. I'm going to give you a lot of background about how I even came into contact with the coal community and what attracted me to it. So when I talk about finding common ground, I want to say for the purposes of this presentation, I want to intellectually agree that facilities that focus on the most important issues and that proact to prevent surprises and deviations from effective operations will be most likely to turn in superior results. I mean, that's a hard one to argue against, but we all have unity and purpose, and that's really where I want to drive this session today. Okay, I'm going to be going through this stuff about, what does reliability mean to me and why why words, why I'm a bit confused. And I've been in this community 8 years and why I'm still confused about how, what words mean and how people interpret them differently. So that's where I'm going to be going. And I thought that this was a great pick from Colorado Springs, so you know who your host and who's behind the curtains about providing these type of webinars for you. And I want to thanks to my team of Dean and Jessica. I even wore the proper attire today, Dean, in terms of this. I was trying to match the picture, so I want you to know that I'm a slave to fashion. Thank you.
You exceeded expectations already, Bob.
Okay, what's a guy like me doing here? My journey with coal started in 2016 when my predecessor, Mr. Bob Nelms, that many of you may know, was on the board, and he wanted me to do a presentation. I had been doing RCA and healthcare for about 20 years, and he wanted to broaden the base of the coal community from strictly just being where its roots are in nuclear and power generation and safety. So I welcome the opportunity. It's a different group and a different experience. And I remember sitting beside Bob and listening. This conference, ironically, I had never heard of Todd. When Todd was speaking, I remember the airline had lost his luggage and he came in and he had shorts and a hat and a great sense of humor. And he said, he gave the story about how he didn't have any luggage and he went on about his way and he never missed a beat. And I found it quite comical, his style as he continues today. But he was using words like HPI and POP. And I had to lean over to Bob Nelms and I asked him, what does that mean? I've never heard those terms out in my circles of reliability engineering and maintenance. And then I started looking around the audience and I recognized that there was a lot of power generation. And I noticed that there was a lot of safety people. And I'm saying, am I in the right place? And then I was wondering when Bob decided to retire, and he had obviously talked with the board, and he had given my name as somebody to replace him. And I was, well, it was quite an honor, but I'm saying, why? Why would I be qualified for this type of position? So I wanted you to see that, how I came in to coal and why I stayed, because it was actually the diversity in opinions which attracted me most. Okay, so here I am 8 years later, and in my horrible PowerPoint graphics here, but I'm still in the fog. Because I live in this world of reliability engineering, and now I spent 8 years in human performance and the other cold topics. And I still see a lot of confusion, at least in my own mind, between how they interrelate. So, really, this presentation is going to focus around what is reliability and what is HPI and what do they have in common and what don't they have in common. So I started learning all these new acronyms, and for those of you who have been around a long time, back in 2016, it was called HPRCT, which is Human Performance, Root Cause, and Trending. Until the rebranding, which Jessica masterfully handled in the transition, we had some new acronyms. We have the HRO, uh, High Reliability Organizing or Organizations, Human and Organizational Performance. Human performance improvement, resilience engineering, and these others. And of course, root cause analysis, which I'm most familiar. But I realized that I've been here 8 years and I don't know where one of these starts and one of these ends. I just recognize that there's a lot of overlap. I sit in a lot of presentations over the past 8 years, and I hear a lot of overlap, and I hear people characterize these differently. And a lot of that is, there's a lot of people in this space now, and you have to have a commercial uniqueness. I know how the marketing world goes, as I had my own company for 37 years. But I'm sitting on the outside, and I'm saying, well, where does operational reliability fit? And then I realized that I'm thinking what reliability means to me is very different than what reliability means in the acronym of high reliability organizing. So I needed to come to terms literally on, how do these work with each other? Because I know from a principle standpoint, these things all work together. So I want to start with the summarized principles that come from HOP and from HRO. And I cited the various books here between Todd's book and Wyke and Sutcliffe. And I know some words have changed and they've been modified, but these are the core principles. Okay, and I'm going to continue to compare those and apply those into where I think they fit in my reliability background. Okay, what does reliability mean to me and why? Well, I'm going to give some history here, and I normally don't do this in these types of presentations, but in order to provide context, I think that it's relevant how I grew up. My father was coined the father of manufacturing reliability way back in 1972. He had, I'll tell you a quick story. And I say this because of the passion that I see, especially with those in the HOP community, and what they believe in and what they fight for. Is that in 1969, my father always had a passion for aviation. Uh, he, in his manufacturing plant, which was a chemical plant here locally, there were three plants tied to each other that fed product to each other. And in one of the plants, he was manager of engineering and maintenance. And one of the sister facilities had lost yield by half their yield in over a 6-week period. And they could not figure out how to solve this thing. So they had people come in from all over the world. But my father's passion for aviation is that he never understood how can an airplane be more reliable than my manufacturing plant? Why can't my plant be as reliable as aviation? So he delved deep into understanding the principles of reliability from aviation, and he started to apply them in his manufacturing plant. And he started seeing phenomenal results. When the corporate had started to hear about those results at his plant, they asked him as a last resort, why don't we get this guy Latino to come in and take a look at this, why this yield problem is occurring. And my father, contrary to what people believe the Latino name and ancestry is, my South American friends are always very disappointed when they ask me to come to their country, and I asked for an interpreter because I do not have a Hispanic ancestry. I'm Sicilian. And being given that, my family from New York, my father is known to be a deal maker. So he made a deal with the corporation, and he said, "I tell you what," he says, "you give me autonomy, complete autonomy, with the cooperation of the plant manager with my team for 1 year, and let me take these principles and apply them." And he said, "If I'm successful, then you will fund a corporate R&D reliability center for the corporation around the world." The company was called Allied Chemical at the time. Today they're called Honeywell. And he says, "If I'm not successful," he says, "then I'll quit." Now, I was too young at the time to realize the bold and outrageousness of that statement, because he had 5 kids between the ages of 4 and 14, and he was putting his job on the line. But he did it because of his belief in that his system would work and that his principles would work. So I contrast to what I see in Hop too, going after what you believe. And obviously the rest is history, because he turned that plan around. Not only did he turn it around from the worst performer in the world, he turned it around with his team to the best performance in the world. So they set up the corporate R&D group from 1972 to 1985. And then from 1985, he retired. He purchased his department out of the corporation, and we became a family business for 37 years. So that's my history with reliability. His principles I'm going to show you focused on equipment, process, and a specialty in human reliability. And I put an emphasis on that because think of in 1972, and you're pushing human reliability. It's hard enough to push reliability because nobody knew what it was. So I wanted to give you that history. I literally had a PM program that I had. Those were my chores at home. Is that our house had a PM program, and the belief was that reliability is not just a job; it's a way of life, and that has stuck with me and my family, since our birth. Okay, so this is another chronology of what that is. My father wrote a book in 1980 called Strive for Excellence, the Reliability Approach, and it outlined all of these principles at the time. And for those of you who know us, this is the 5th edition of our current text, but in memorial to our father, we stole his cover, and because it's very fitting for the topic of root cause analysis as well as the topic of reliability. This was his original fashionistas, the original reliability team from the 70s. And I purposely show you this because I want to show you this gentleman off to the left, and I'm going to connect the dots right now. This is my friend, Mr. Bob Nelms. He was part of my father's original reliability team. We shared the same beliefs. His career followed along the same path with fail-safe networks, which many of you may know. And this is Bob today. And a quote that we commonly use is, "Everything you need to know about improving your business is contained within your failures." Okay, I'm going to start. You'll see me using these little red boxes. And this is where I'm pulling the principles of HOP, and I'm pulling the principles of HRO, and I'm applying them to, my version of what reliability is. As part of the R&D team, I said they focused on equipment, process, and human reliability. Dr. Ivor Davies was a renowned instructional technologist that they hired to come in and assist with spreading their message. And this was in a paper that he wrote, that it tasked trainers with the responsibility of setting up conditions to systematically reduce the probability of error, both in the acquisition and execution of human performance in work situations. What I'm trying to do here is to say that our original reliability approach, that the most critical aspect of it was human performance. A definition for those interested of reliability in a manufacturing plant that I prefer is the ability of a manufacturing plant to safely deliver the maximum quality product on time, in full, at the lowest sustainable cost. So I use that as my go-to for when I have a need for defining reliability. Now, the simplicity in my mind, and sometimes I make it black and white when there's a lot of gray. But simply to me, reliability equals proaction, and proaction equals no surprises. So that I see the world through a prism of proaction as to I don't want to get better at fixing things. I want to get better. I want to understand why I'm having so much practice fixing things. I shouldn't be doing that. Okay, so the core principles, I showed you hops and I showed you HROs. I wanted to show you now the ones that work in the 70s. Priority, proaction, and focus. Priority comes from leadership because that's what if leadership is supporting the proactive activities, then they will show it. So after a failure occurs, a lot of us are really familiar with that the plant manager is going to come down and then they're going to say, when is it going to be up and how much is this going to cost? Well, a reliability focused leader is going to put the priority on proaction. They're going to want to know what caused this to happen first. And first of all, is everybody safe? And what are we doing to find out why this happened so that we can prevent this? That's a big difference in attitude for a leadership. And then, focusing is, are we working on the right things? We have a tendency to work on the urgent, but when everything is urgent, nothing is urgent. Okay. So we have to be able to separate the urgent from the important. And the important is usually going to be the stuff that takes proactive means to go ahead and resolve. And then on the proactive side, we have to be able to any improvement, foresight, and or execution activities that will prevent equipment, process, or human failure or lessen the consequence of failure. This is a truly proactive view of the world and saying, I'm not going to get better at fixing it. I'm going to get better at finding what could happen. Okay, so this makes I'm pulling another principle. How you respond to a failure matters. If you respond that I want to fix it as fast as I can and keep moving, or do I want to understand why it failed in the first place? I want to be able to, I want to go through this and say, where does reliability live in an organization? I want to be able in this to be able to, you can go ahead and take this poll, but for the sake of time, actually, I'm going to just tell you where I wanted this to land. Is that these are the options of where reliability can live in an organizational chart. Okay. And I'll show you the poll results because I put this out on LinkedIn earlier. Is that reliability reports to the maintenance manager, reliability reports to maintenance, who reports to ops. The reliability manager reports to the site manager or to engineering. Now there's an sundry of these things all over the place. Okay, to be able to do this. But what I want you to see is that in its infancy, why would C be the ideal answer? And if you can go ahead and put in chat, I'm going to say, why would C be ideal for why reliability should report to a site manager as opposed to subordinate to the other ones that we talked about? I'm kind of curious.
So we're starting to get some responses, Bob, and the first one in there is reducing conflicts of interest. So kind of equal level. No barrier to incorporating reliability. Another one is avoid filtering the truth. Interesting.
And those are all along the same point that I want to make, is that if you believe that reliability is a proactive function, if you subordinate it to maintenance, which is a reactive function, you will do very little reliability. Because if I am charged with doing both proactive and reactive activities, say I'm an engineer and they've changed my maintenance engineer label to a reliability one, then I will do very little reliability work because I will be chasing failure all the time. So the reason C would be ideal for us and the way that we had executed it would be to remove the filter and isolate the reliability group from the maintenance so that they would not be having to deal with the day-to-day failures, but their job is to prevent failures tomorrow. Okay. So this is as of yesterday when I was doing this, I put it out that about half of the people have it that way. And then the other half, say 36%, was subordinate to maintenance. And I do see it in reality, I see it a lot more subordinate to maintenance. But I wanted to give you the reason of why it should be parallel to maintenance. Okay. So now I've talked about reliability, I've used it, and I say, what the hell is it? I'm going to go through that now. I first want to ask everybody, what is an asset? This is another one of Dean can pass me these answers. Is in your organizations, if I was to ask you what is an asset, what would you tell me?
Yeah, so we got a number of good responses last time, or a number of responses last time that were great. And let's see what we get for this one, Bob.
In your organization, what is an asset?
So first one in is a piece of equipment that adds value as long as it works. Something owned by the company, people again, a source of value generation, people or equipment, anything of value. So a lot of stuff that's right on target, in my opinion. Bob, what do you think?
Okay, and I want to thank you for this is why I suspect that I'm going to go over my hours because I want this interaction. Is that I want you to consider that when you look in Webster's and you say what is an asset, it's described as property of some type. It's owning something. And while we all hear the 10K reports, on the annual 10K reports where human beings are our greatest asset, we have to understand that when you go ahead and go to page 54 of your 10K report, the equipment is an asset and the human beings are a liability. So from our GAAP accounting principles, we have to look at those and we have to be able to define in our own organization what is an asset. Now, this is a key language barrier, I think, between the communities of reliability and safety, in saying that in safety, certainly the human being is the focus of the asset. And a lot of people believe that reliability, fixes broken stuff, that equipment and components is all that stuff reliability people do. But I'm trying to broaden the understanding that reliability is equipment, process, and human reliability. That human reliability is critical to why undesirable outcomes occur. Now, we've seen in this unfortunate crash of the bridge, which, I'm in Virginia, and this is just north of us in the port, and we deal with the Virginia International Terminals and the Norfolk Port, who will be impacted by this economically because they're going to have to take some of the traffic that can't get into the Baltimore port over here. I want you, when you're looking at this, is this if I was defining what is the failure here, is it the six deaths, and or is it the fact that the ship hit the bridge? I'm not going to go into that right now, but I want you to be able to look at this, and when you're looking at the problem here, and it's really hard to see because it's dark, but one of the things that would be highlighted in this is that the lights on the ship went dark, and you see a black puff of smoke coming up over here. So those are going to be two things that they're going to be delving into and trying to understand as part of this analysis. But those are going to be likely in the mechanical realm. But the mechanical realm is what contributed to the death, because if you didn't have the mechanical problem, you wouldn't have put these people in compromising positions that unfortunately uh, it appears have passed away. I want you to liken that to the people as old as me. You go back to Space Shuttle Challenger, and this was right on the launch pad. It was seconds after firing the solid rocket boosters, and you see these puffs of smoke sitting here. That had to be explained because that's evidence of a leak of solid rocket fuel. So, in looking at these through the eyes of reliability, yes, we have people harmed, we have fatalities, but they are due to the mechanical type of things dealing with the ship. However, you lost power is going to be a big focus on here, and whether there were backup emergency systems for the steering and automatic anchor drop or whatever the case may be. A lot of people speculate, but right now you don't know. People are in data collection phases right now. All right. As a process, what does reliability look like? This is the model we've used for 40 years. A lot of people believe root cause analysis is works in a vacuum. And I go out and I do a 5 whys, or I do a fishbone, or I do whatever. I wanted to show you that in the eyes of reliability, root cause is just a very small component. I want you to understand that when you're looking at a manufacturing facility, that the strategy part is that we have to determine what is the criticality of the assets. Like my brother's paper mill that he worked at, there was 50,000 assets at that. You can't treat them all the same. You have to be able to come up with a strategy to protect those assets based on how likely they are to fail and their severity. So when you come in here and you have asset criticality, you're going to be able to identify what needs more attention. And then you're going to put into place all of these asset strategies to protect that piece of equipment. It's going to be, our spares part inventories, operator-driven reliability, where operators go out and do and help with the inspections of the equipment, the time-based maintenance, the predictive-based maintenance, our lubrication schedules, our procedures and our processes. The things that are higher priority are going to get more attention. But this is the strategy to protect the asset. Okay.
Hey, Bob,
Yes.
I'm just going to pause or interject real
Sure.
quickly because we got a couple of comments about, and sorry, this is maybe going to take you back a little bit, or it might fit in perfectly right here. Do with it what you will. But a couple of questions around humans or people as assets or liabilities, and there were some comments about what you meant by that, and also, a comment about someone having a little bit of difficulty with humans being an asset because organizations don't own humans. So can you just help clarify that a little bit?
Yeah, I'm saying on the books, I was making the case that society will class humans as a liability because of our accounting principles. But certainly from a social standpoint, our humans are what run our equipment and run our organization. So they from that perspective, they are definitely an asset. But when you have failures, you have failures that and this is something I don't understand myself, is because HOP seems to be related to safety incidents, and I'm not sure when I'm looking at safety incidents. I'm saying a lot of cases people are hurt when they're working in an operation during unstable operations, and they're more likely to get hurt. So am I looking at how the human got hurt itself, the exposure and all that stuff, or am I looking at the source of the failure, the mechanical failure? Say I'm in an oil refinery and I had a crude unit have a problem, okay, and then it released gases to where a person was in the area and the person was affected by it, okay. So as a reliability engineer, I'm going to find out how were the gases being released that put that person in danger, as opposed to just looking at the person as the analysis and saying, why were they in the position that they were in, and how could they be exposed to the danger? I would be looking on the mechanical side of saying, why did the danger exist at all? I don't know if I'm making myself clear on that, but in a lot of these cases, I'm not sure where the analysis starts. What's the event? It seems to be different to me than it would be in the other communities. And I think that there's a parallel, there's a unity here in the sense that the person would not have been in danger had the mechanical thing not occurred. So that's really where we focus on is understanding the risks and the dangers and preventing them from happening so that people are not put into a position of being in danger. That
Thank
clear,
you.
clear as
And
mud.
I'm going to go out on a little bit of a limb here real quick, Bob, if I might. And
Yep.
Amy, I'm going to ask Amy to unmute herself because Amy sort of like kicked off this little bit of just questioning about
Sorry.
there you go, Amy. Bring it on.
No, it was literally, it was a case. So I'm from England, and so I say weird things, but it also means apparently I don't understand American accents all day long. And so I wasn't sure if you said humans are reliability, like reliability is life and our humans are driving it, like yay. Or if you said humans are a liability, and the words just sounded so similar that I was really a bit confused. And I literally wanted that clarity, but then thankfully I posted in the chat and various different people kindly replied to me and were like, oh, I think it's liability from an accounting term, which apparently that person, high five, they got it right, thanks Andy. And then Dean was saying, no, I think he's saying reliability because the human. So I think maybe what you actually meant to say was both, depending on who's looking at it. And then the question is, do we look at the machine or do we look at the human, or how about we look at the complex interaction of the both of them and just dive down all the pathways? But I think you've answered my question. I'm happy. So thank you for the help, guys.
Thanks for
And,
jumping in, Amy.
Sure.
and I'm going to make it clear about those interactions, but that is I'm saying from a accounting perspective, we call people liabilities, and that we can talk about our financial reports and everything about our humans are our greatest asset, but we're hypocrites when we turn over so many pages and we say, well, the equipment is actually the asset and the humans are a liability. Nobody's going to say that their humans are a liability in general because they are responsible for running everything. So that's the point I wanted to try and clear up. When I'm looking at strategies here, they don't operate by themselves. That we have to have a means of executing them. Okay, so this is work maintenance execution systems. This is your SAPs and CMMS systems, operational work processes, and then our big capital engineering work. This is a few blocks, but it's your lot of bigger systems, the execution systems. So we have execution systems, we have well-intentioned strategies, and then life sits in, and then things slip through. When things slip through, and then we have, like, say, our predictive maintenance people pick up high vibrations above alarm limits. Well, when they slip through our execution systems, we're notified of that, and then we want to go ahead and before it fails, we call this a primary risk. If we go ahead and act on the primary risk, then we will avoid the failure and that we will go ahead and fix it. But then things happen that we don't identify. They slip through the systems, and then we have chronic and sporadic failures. Then we have to do root cause analysis and understand how it got through the systems we have set up. Then we implement the corrective actions, and this ends up being a feedback loop, which goes back over here to asset strategies and say somehow our strategies and our execution failed us. So we need to go ahead, and we found we have deficiencies here. We're going to go ahead and fix them here. I want you to look at this again. I'm poor with PowerPoint. Look at this as a piece of Swiss cheese, and each vertical column here, if you took that piece of cheese and turned it sideways. Okay, so the holes are going to be parallel with each other. What I'm trying to say here is that as we operate, there's holes in the cheese all through our strategies and our execution. And then eventually, if they all line up on a given day, then we're going to end up having something slip through. We're either going to catch it before it fails as a near miss, or we're going to not catch it and we're going to have to deal with failing safely. Okay? So this is showing now that this is what I mean by priority, proaction, and focus. Okay, and root cause analysis is it's a way of understanding how to think through something. It's not industry specific. I do this in healthcare. I do it in schools. I do it in banks. I do it all over. I don't care the nature of the bad outcome, because how you think through it is going to be the same. Okay. Over here, my red box, I'm pulling another principle. The commitment to resilience from the HRO side is that putting in strategies here is a commitment to having plans in place, especially to have them fail safely. And over here, I'm acknowledging that when you got through all the slices of cheese here, that people make mistakes, and then we have to be able to compensate for it, and again, failing safely. Now, from my standpoint, and what I admittedly don't understand because I'm not a safety professional, is that if we define the human as the asset here, and then we have to go in and the asset criticality is going to be, some people are at higher risk than other people. What are the systems that we put in place as asset strategy? How do we protect our people that are put in, some are in higher risk and some are at lower risk? And then what are the execution systems that we put in place to make sure that those strategies are implemented? And then everything follows the same. We will have things that slip through the system. We will predict them with whatever indicators before it happens, and they might be near misses, or they will happen, and then we have to go through and learn from them. I don't know what these are, and I'm not the SME to give that up, but there are certainly many in the coal community who are, and that's where I can learn. Okay, this reinforces the learning and improvement are vital principle, is that this feedback loop right here is that root cause analysis has to be fed back in, and it has to strengthen our system organically all the time. Okay. All right, what is the role of RCA in a reliability system? Well, you can't do true root cause analysis, full-blown, in-depth on everything, right? So we have to be able to separate the chronics from the sporadics, because we're going to use different tools for these. I did want to show you that in my world, we put these into buckets. When you have failures that occur, they're broken into three categories for us, into triggered, chronics, and defects. Triggered events are going to be the ones that they're either regulatory based, but they're certainly defined in your organization, clearly defined, that when you've hit a threshold, that you are going to do an RCA on these full blown, whether you like it or not, because the suits are going to show up. Now, in these, a example of a triggered event might be where on any single incident, we've exceeded 6 hours of continuous lost production. We've had an incident that has exceeded $250,000 in single cost. We've had a reportable injury, or we've had a fatality. Those are certainly called triggered things. Now, chronic failures are going to be things that do not, on their individual occurrence, reach the level of a trigger, but they become a cost of doing business. I'm going to use conveyor trips here. So organizations, especially like in mining, that that they convey things in long distances, miles, is that if I have a conveyor trip and it only takes 15 minutes, and somebody has to reset it or clear it, we're not looking, if you looked at the individual occurrence, it might cost the organization $1,000 between materials, labor, and lost production. Well, if that's happening 1,000 times a year through all of the organization, then now that far exceeds any single incident that you've had. Oftentimes, chronic failures are just we get so good at fixing them that they're not a failure anymore. They're part of the job. And then you get down into defects, and defects are going to be all the things that remember I talked about strategies. Defects are going to be the things that I want to talk to the field about, and they're going to tell me anything that gets in the way of them doing the job the best that they can. They're going to tell me that the procedures are obsolete. That's why I don't follow them. They're going to tell me that when I go ahead and get to the job site, that the wrong materials are there. They're going to tell me that when I go to the job site, that the crane doesn't show up for an hour, so we're all idle. These are things that aren't in your recording mechanisms, but they piss off the people that are on the front lines. And that this, to me, is more where HOP is associated with this. This is our version of HOP. We call it defect elimination. Is that going out and learning about all these things that frustrate the people in the field, and that we tend to not listen to them. So here, going to the principles, is that we have a preoccupation with failure because we're not only following the triggered things, we're finding all of these things that are reported and unreported. And we're doing it with the field. Okay, where does failure come from? This is a slide. If you ever listened to me before, you're going to be ad nauseum tired of listening to it and seeing it. But this is one that clears up a lot for me, is that where does failure come from? These represent our systems, our organizational or management systems. When these systems have holes in the cheese, they provide people inadequate, insufficient, or non-existent information. Okay, these are the decision makers. So they have to trigger a decision. They have to make a decision that triggers other things to happen. When they make a decision, it comes out of their head now, and now they are taking an action or choosing not to, and they are triggering a series of cause and effect relationships that the key here is they are observable. Okay, I can see these things now. I can't see why people reason. I can't see how they do that in their head, but once it's out of their head, I can see the consequences of that decision. Now, this blue arrow here represents those thresholds of a trigger I was telling you about. That if we don't break these chains through the preventive and predictive maintenance and inspections, then we're going to have an undesirable outcome and suits are going to show up. Now, I like to make the point here that when we do break the chain, it often becomes a decision as to whether we do an RCA or not, because the consequence didn't happen, right? We got lucky. To me, a near miss is we got lucky. So now the consequences, what we want to be able to say is, well, if I'm really busy, I don't have time to do the RCA. So if that's the attitude, then what we have to just understand is everything that led up to that point of getting lucky is still there. The system is still geared that this will happen again, and you might not be so lucky next time. All right, for labeling sake, I call these latent root causes of these organizational and management systems. I call the decision error itself, the act of making the decision, a human root, and that the consequences of that decision, the immediate consequences, as physical. Okay? Now, this is what I want to stick in people's mind as to the hourglass. I call it the hourglass approach. And I want you to realize that the yellow up here represents the physics of failure. This is all the mechanical stuff and the stuff that people believe that reliability only deals with is the physics of failure. The H is the human, the decision, and that in the blue, this is all the human stuff. This is all the social sciences. This is all the physical sciences. A lot of people who do RCA focus on the decision outcome, and that becomes a problem because that's where I'm starting to look at blame. But if you're doing a decision RCA on decision outcome, then we're just focusing on shallow cause analysis. We're not doing root cause analysis. Unless you're interested in understanding decision intent, we're not doing root cause analysis, at least per our standards. So using some more terms that I'm learning in the coal community is that the yellow really represents the mechanistic systems, and that the blue represents the adaptive systems. Okay, here, I'm trying to, I can't see which one here because it's covered up by my panel here. Blame fixes nothing. So if we stop here and we blame somebody, you're missing all of the reasons, the reasoning for the decision. Context drives behavior, because I want to be able to focus on understanding why the decision at the time made sense. This is the sense making. Okay, I know I said that undesirable outcome here. I use it synonymous with event. I give this to you as one that you may consider. Some good friends of mine that developed a thing called the manufacturing game, and his book, Don't Just Fix It, Improve It. The definition of an event is anything that erodes value, reduces production, compromises health, safety, and/or environmental performance, or creates waste. I talked about earlier about the prioritization and the triggering. It doesn't matter what department you work in. There's different triggers for different departments. You call it whatever you want. Safety will have one that's going to be different than your stores or your purchasing. Everybody's got different problems, but the way you think through them is the same. Okay, here's my graphic. Most people use a really lively tree with a bunch of leaves on it in the spring. It looks beautiful, but the fact is, if your systems are working, you might have that kind of tree. If your systems aren't working, then you're going to have a dead tree. So what we tend to focus on are the consequences of failure, but really underneath here is going to be the intent. This is the hows, and this is the whys. And this is what we typically don't see is the, why did people think it made sense at the time? And this is where the strength of the HPI tools comes in, is understanding why good people make bad decisions. And that's how RCA, people in the RCA business need to get better in the blue area of the social systems. Okay, I'm going to quickly go through this, and I'm going to, let's see, out of here and go into trying to find out how to get rid of this toolbar, this panel thing. Oh, okay. Bear with me while I move my little control panel around. All right, I'm getting in. I'm in that red block of what is an RCA, and I'm going to say this is how we approach it. Is that we're going to demonstrate cause and effect relationships. In this case, the event was an unexpected outage of so many hours, resulting in so many dollars of loss. How did that occur? We had a critical pump fail, and the question becomes, how could a pump bearing fail? Now, this is where you're using your crafts and your SMEs, but the only way a bearing can fail is because of erosion, corrosion, fatigue, and overload. How do I know that that's true? Is because I have evidence here that says we had a metallurgical review, and that review proved that it was not erosion. If you don't have SMEs, subject matter experts, then you can have systems that will go ahead and say that AI is everywhere now. You can go in and say, well, how have other people answered the question, how can I have erosion? Go ahead and pick from a list. Just use Chat GPT. It's everywhere. How can I have fatigue? I can have it from high vibration. This is proven to be true. And then how can I have high vibration? I can have misalignment, which is a people thing. People go in and they align equipment. And in this case, they did not align it properly. Well, now we're getting into, when you get to a human decision maker, we switch the question from how can in the physics to understanding now why would that person make that decision at that time. And this gets down into the system stuff. I'm still following that hourglass approach and saying that they were never shown how to do the job right anyway. Somebody retired and you gave it to me. The tools you gave me were not adequate. They were obsolete. And then LTA stands for less than adequate. Management oversight is how come I didn't know somebody was in a job who was not qualified? And then you have your corrective actions down here. The green things just mean that we assigned tasks to do, they were done. The red just means that they were assigned and they're past due, and the yellow means that they were assigned and not due yet. Okay, bear with me. Let me see what I'm working on the time here. Okay, I for the sake of time, I was going to show a video. Dean, you probably think that I don't have time for a video, do I?
Well, yeah, it might be a little tight.
Okay, let me go ahead and make a point. All right, I'm not going to get into the, I had a video describing this very tragic event, but this was the death of a 6-year-old boy while taking a normal MRI. And it turned out that while he was in the tube, that he was losing oxygen, and the doctor was freaking out because he couldn't find another oxygen canister, and the text, the oxygen supplies there had been depleted. There was an array of things, but a well-intentioned nurse had entered the MRI suite in good faith and well-intentioned, and she found a canister that was in one of the holding areas near the door where the doctor was yelling. And unfortunately, she brought that canister into the doctor, but it was a metal canister, and that it was drawn immediately into the tube, and it ended up killing the little boy, unfortunately. So I wanted to bring that up. I want to show you this from the big picture, and saying, I'm not going to go through all of this, but the red things are all going to be systemic issues, okay, as I talked about. I'm going to go in here, and I'm going to, bear with me. I just want you to be able to see that this is not a mechanical one, because the MRI itself didn't fail. It performed as it was supposed to. Somebody had brought in a canister to go into the room. It was drawn into the tunnel. So therefore, somebody had to bring a canister, had to get into the room. Okay. So I asked, how could that be? And there's numerous ways in which it could come in. We have to study the possibilities. But then we come in here and we say that canisters were introduced into the MRI room by the anesthesiologist and the nurse. Okay. How can that happen? Well, the MRI room control desk was unsupervised. The two people trying to figure out why they couldn't get oxygen were in another room. One of them should have never left the control room. Why wasn't the patient removed from the MRI room to get oxygen outside of the dangers of an MRI suite? inadequate physical security. Why was somebody able to get into the MRI suite without being blocked? Why wasn't the backup oxygen supply readily available? Why were canisters, metal canisters in the room across from the hallway? And then, there was other piped in supply issues. I just want to be able to show you from this is that when people talk about RCA and RCA being linear, that in the reality that's not the case. So let me show you this. I'm going to go back out. So imagine if you had done a 5 whys on this. And again, we don't need to read anything on here, but if you go 1, 2, 3, 4, 5, then think of all the things that you would have missed underneath here, and that these are all systems issues. These are all holes in the cheese of systems that contributed to people making decisions that could have been better. And as a result of those decisions, with great intent, this failure was permitted to occur. Okay. I'm coming around turn 4. So my point with this, with the principle, is there is a reluctance to simplify. In this, if I was in a hurry and I do a 5 whys on this, you would have been grossly incomprehensive. Okay, when I look at this now, and I look at this as a system, saying, why do we have to wait for failure to occur in order to find these holes in the cheese? Why do we have to wait for bad things to happen in order to identify these things in the red? When the reality is that if we went ahead and we approached our people, when you go to the field and you give them things like, the procedures were obsolete. You always let me do the shortcuts. This is nothing new to them. They just don't tell us anymore because they've told us before and we do nothing until a failure occurs. So I'm all about the principles of HOP and being able to use it for foresight instead of hindsight. So we should be engaging the field, and we should be out there looking for these systems that are failing them. Context drives behavior. This is why people make the decisions they do. All right, last section here, and I've been hearing a lot of the words of complex versus complicated. This is going to be my reality check. This is my hourglass that I was telling you about. If you stop short and you only look at broken parts, that's a shallow cause analysis versus a root cause analysis. The reality is, in my world, is that I deal with what I can control. These things are internal. These things are internal. These socio-technical factors I hear about, they're external. And the difference in asking how can versus why. That's a big difference because physics doesn't change much. So I want to look at all the possibilities and not what's the most obvious. And that's exactly what they're doing with that bridge collapse right now, is that they are looking for the facts of how that could happen. Now, I've heard these words complicated, complex, and chaotic, which are $7 words to a guy like me from the academic world. And I'm trying to put some meat to it, but I went ahead and I've done some research and talked to some friends. This is systems thinking, and these are systems models. This one has to deal with Congress and campaigns and all. These are all the interrelationships, and that is pretty complex. Wait for it. This is like a local health departments and all of the external influences that they have to deal with. This is the world peace. Now, I don't operate in academia, and I can tell you that this is very chaotic looking, but every circle you see here that's connected to another circle is a cause and effect relationship. But all these interdependencies do make it complex, and they make it chaotic. But for people, I put this picture in here. We've all seen this. When I looked at this, because I don't know, I can't explain that. I don't know what the hell it means, but that's what it made me think of these pictures that we see about all these wires. All right. Some academic friends of mine, I think it's called the confines framework, look at the range here from simple to complicated to complex to chaotic. In my world, the simple stuff lends itself more to five whys. Just the simple five whys is linear. When you get into RCFA, which is root cause failure analysis, and you stop and you're looking at physics, that can get complicated if you don't have the right people, especially. But then when you start expanding out into our organizational systems that influence decisions, that gets more complex. And then the chaotic, you saw the pictures that I gave you. So the point that I want to make here is, in my reality, is that outside of the fence of where I work, if I have to go into the chaotic and the complexity of dealing with regulatory agencies or insurance companies or whatever the case may be, I don't care. My solutions and my corrective actions are going to be things in which I can control. And if this needs to be thrown over the fence to people higher pay grade, that's fine. But I'm not interested in getting into that kind of stuff. All right, what do I learn from HPI and my whole coal thing? Is say that we're all in the business of asking better questions. And that's really what I have learned the most from my 8 years with coal, is that I used to question, and in hindsight I see this, I used to question like I was in a interrogation, and it wasn't a conversation. And I've learned how to be more subtle in my questioning, that when we get to that, you remember, talk physical, human, and latent. When we get to that human and we're questioning people, we're not saying, you were trained, you had the right procedure, and you still didn't do it right. What's wrong with you? That type of attitude. Is that I now have learned from you guys, one of the key things is I start off with, what would right look like? On that day that this happened, what would right look like? And I can tell from that answer whether they knew the correct system or not, and be able to take my questioning on from there as to, they didn't know what right looked like. They've been doing wrong successfully for a long time without incident. Were there any surprises to you that day? Was there anything anomalous? Tell me about the times you've had to deviate from procedures and why. Because if I have to build a shortcut, that's a hole in the Swiss cheese of the systems. So this questioning has been very helpful for me. Okay, and that's I think that we have unity and purpose when it comes to that. All right, recap is looking in hindsight now. You've been looking through my eyes, which sometimes is a very pretty sight, especially if you're in the mesh of what's in my head. Preoccupation with failure. Reliability engineering and RCA, absolutely, is that we have a preoccupation with failure. Remember, I told you triggered, chronic, and defects. Just because it didn't cause a catastrophe is not going to matter. We have a reluctance to simplify. We're not going to do a 5 whys on everything. You're going to have more failures if we take that attitude. I can't conceive of doing an RCA without field people involved. I don't know in organizations, other organizations, but when we deliver what we do, the field is part of the analysis. Commitment to resilience, how to fail safely, as we showed you in that model. Things will get through, but they won't kill people, is that they will fail safely. Deference to expertise simply is, if I don't know the answers, I'm going to find somebody who does. If I don't know how a bearing fails, I'm going to ask somebody who does. All right, same review and reflection here. In the HOP principles, people make mistakes. As you can see, it's embedded in the C model that we showed you. Blame fixes nothing. I'm not one that says you swing the pendulum of blame all the way to the other side to where people take more risks and say, well, they're not going to blame me, so I'm going to take a shortcut and use their own words against them. We can't let it be an exemption for accountability. Learning and improvement are vital. For me, who is a purist in the RCA space, the purpose of an RCA is to create a knowledge management system where all of that logic that I've been showing you, it goes in stored, and then we can use AI and we can use search mechanisms to go in and say, you know, how has this happened before through somebody else, and what kind of learning have we had from it? And how you respond to a failure matters. Is that leadership should be not only it's their duty for fiscal responsibility to get the plan up and running, but it's also their duty to understand what led to that happening and to emphasize it. You know, we're not going to wait for it to happen again. All right. Lastly, for my overrunning, those who say something is impossible should get out of the way of those people doing it. Because I hear that all the time in my line of work. Okay. So with that, Dean, I have exceeded my time, which I asked for forgiveness in the beginning, but I'm open to taking some questions.
The journey was well worth it, Bob. So thanks for the extra 9 or 10 minutes. We appreciate it. And I'll pause here and see if anybody wants to offer any questions or comments into the chat box, or to raise their hands and just ask live. So we do have one already, Bob, and it's I'm more curious I'm just curious about how stock buybacks lead to lax quality and maintenance for both manufacturers and carriers. It's an interesting one. It might be beyond the realm of this kind of conversation, but do with that what you will, if you want to take on that kind of comment. But it was building, I think, on a previous comment in the chat box about COVID impacting the maintenance environment and, you know, the why of things and why they happened. So just a couple comments that showed up in there.
Well, I'll address
but I will
that.
Pause to see if we have any other questions or comments. But
You know, I was gonna, when you're talking about the COVID kind of stuff, that is gonna. I wanted to be able to show you a couple of analyses, one being mechanistic and one being the MRI one, because I wanted you to be able to see that the questioning structure, you can go as deep as you're comfortable with, because I could easily get into complexity and into chaos if the deeper I went in that. But if I don't have any control over acting on it, then it's a waste of my time as someone working in the plant. But if I felt that was, and the people in the plant, it was important enough to look at that from a social standpoint, a society standpoint, and be able to look at the impact of COVID on their workers or the quality of workers or whatever the thing may be, then you can use tools like that to go do it. But it's got to have the, how appropriate is it, and what's the reality that you're going to be able to do something about it. I'm convinced you can find deficiencies to do something about it and corrective actions, but can I get anything done with it?
Okay, thank you. So one question, Bob, I'll take you back to your reliability process flow. And the question is, why would design reliability not be part of the strategies component of that process flow?
It would be.
Okay.
And I think I had something in there about design modifications and capital work. But yes, and even if I had missed anything in there, just add another blue block. But the point is that we should have asset strategies for the criticality of the equipment, and then have a means of executing them. It's a very valid point, and if you're a reliability purist, then you are a firm believer that reliability starts in design and then goes through the life cycle of the product, as opposed to just after it's been commissioned, then we start reliability. That's not the case. Is that reliability starts in design.
Great. And while we're waiting, I'm waiting to see if we have any more questions or comments that come in, Bob. And I have a curveball for you. I think it's a curveball. I'm not sure. But my work has all been around like organizational culture and leadership. And I'm wondering if any or all of the strategies, the approaches that you've just talked about, like we tend in an organizational world to focus on negative deviance. Can we ever use any of this in terms of positive deviance? What went right? What can we learn from it?
I'm going to say yes, but to me, it's more difficult because I know that this is one of the tenets in some of the communities I've been dealing with. And when you look at it, it's easy to identify the things that go wrong. But say 1% of the things that go wrong, and then you have 99% of the things that go right. How do you determine what you're going to focus on to do the 99% of the things that are right? Because we don't have enough resources now to address the 1% of the things that go wrong. So how am I going to parse the 99% and say, well, these 10% of these are had better outcomes than the others, and then the thing, everybody distances themselves from an RCA because they feel there's going to be punitive actions against people. But when you go in and you're doing something on the positive where there's credit that's going to be doled out, then everybody wants to be a part of it. So
Right.
you're going to have people saying, well, I created the training systems that contributed to that. Well, I run the powerhouse and you had lights. I buy the parts that worked. So I can see that getting into the chaos type of thing of everybody jumping on board. And I'm not really sure which ones you'd look at.
Great point. Thank you. Let's see. So we have one more comment. I think that'll be about all we have time for, Bob, before we wrap up.
I want to make a quick comment. There's this thing that Jay, our friend Jake Nazalevitz, he told me about this talk, and I don't even know if the thing works, but I made sure I didn't ask you for your email things.
Nice.
So we'll see.
So the comment or the question is, do you have any examples where you tried to build or grow or influence change with regulators, manufacturers, or even government policies? So like that external stakeholder kind of influencing or change perspective.
Well, I'll give an example which I know is pertinent in this community, especially with the government labs. Is that they're heavily regulated, and when they regulate, they cite deficiencies. And we've worked with many organizations to understand the source of the deficiencies to respond back to the regulators. And even we had one of our clients who's in the ports and terminal businesses is that they had a rather serious incident that OSHA was involved with, and that they worked with this type of process with OSHA, and that OSHA, was not only they had a buy-in because they were part of it, but they absolutely loved the format in which it was, because it made the clarity of understanding, the how, cans, and the why, and that evidence had to be able to be there to support it. So they really appreciated the format.
Awesome. Thank you. So with that, I'm going to wrap things up here, Bob. So Bob Latino, thank you very, very much for your time and your insights. And for everybody that has, if you have follow-up questions or comments and want to reach out to Bob, you've got his email address and contact tools right there on the screen right now. And just a little bit of a plug for some upcoming opportunities. Our next webinar is on April 23rd. That's a Tuesday. We had to shift from our usual Wednesday model. So Tuesday, April 23rd, Dr. Martha Acosta will be talking about accountability and blame and building a healthier culture and models within organizations. So that'll be a great one to follow up on Bob's great talk today. So please put that on your calendars. And of course, for those of you who have not already taken a look at and registered for our annual conference in mid-June, please do so. It's going to be a great learning opportunity and opportunity to meet and share and connect with your colleagues. So with that, thanks for the time, everybody, and have a great rest of your day.